Welcome to the 2023 Winter Classic Student Cluster Competition Studio Update Show. Now, here are your hosts, Dan Olds and Addison Snell.
Hi, everybody, and welcome to another 2023 Intersect 360 Research Winter Classic Invitational Student Cluster Competition Studio Update Show. I'm Addison Snell alongside Dan Olds. And Dan, today we are joined by Platinum sponsor and mentor HPE, who's done a lot to bring us this student cluster competition. The first results are in the books. HPE hosted the students for high performance LINPACK and HPCG, and they're going to join us to talk about what it was like to work with the students.
Yes, they are. We're going to crawl now kind of underneath the curtain and see what it's like to be a mentor. So let's go ahead and bring in the HPE mentors now. This isn't the full team. Not everybody could do this because of time constraints, but we've got Cheng Liao, we've got Chris Marsh, and we've got John Barron. Welcome, guys. How you doing?
Very well. How are you?
Thank you.
Very good. Very good. And
Cheng, Chris, John, thank you so much for you and the team working with the students on this. You know, we need the sponsorship. We need the mentorship. This is what's making this student cluster competition work for these schools and these students.
Tons of fun.
Is.
It was a thrill. So,
and I think all three of you, this is your second year doing it, right?
Correct.
Yes.
Very good. Very good. So what kind of system were they running on this time?
So my name's Chris. I'm in the training department at HPE, and we have a HP Cray EX supercomputer, effectively the same platform that a lot of our HPC customers use. Frontier, notably in Oak Ridge, Perlmutter and at NERSC and other large customers have. Very similar, probably a little larger platform.
A little larger, yeah.
But we have the proprietary liquid-cooled EX cabinet with a slingshot interconnect. And our system has AMD EPYC second-generation Rome processors. And that's what the students were using for this competition. But it's the machine that we use for all of our training on Cray system management and the Cray programming environment. That's the system we use for that. So
serious hardware. We're not playing around
so.
Here.
Yeah, roughly $1 million, give or take. I mean, I couldn't exactly put it on eBay, but
yeah, that's probably about right.
Might as well throw them right into the deep end. Here's a DOE or supercomputer top 500 class system to sink your teeth into.
And I have in the competition had several students ask me, "Is there anything I can do to break this?" I mean, is there something
the answer
I should
is
be
probably, yeah, sure.
Yeah. I said, if you really tried, maybe, but probably not.
This is why we got training.
Yeah, that's why we have training. Actually, that's what I should do, Addison, is give them that answer, go, yes, there are ways you could turn this into a heap of slag. So you better pay attention because you will be billed.
Did that happen? Did anyone break it?
I don't believe any of the students managed to do anything wrong. We did have a couple of real world HPC scenario outages that will happen.
Sure.
The training system that we use is a test system for a new coolant. And we have been, for the last few months, been battling a coolant issue that I'll spare you the details, but we get bubbles in the coolant loop, and bubbles are bad.
No.
Yeah,
bubbles are bad.
That is not the focus of this particular studio update show, but it is interesting that the students get to see, like you said, a real life wrinkle that'll show up as you run an HPC environment.
Only question I'm going to have on that is when I've done that with my liquid cooled systems, you've got to tilt them. To get those bubbles. I take it it's not the same thing.
Well, close. So we had to burp it. That's the expression we use. And I do need to make clear, we have extra plumbing apparatuses because it's a test system. So our customers, I'm not going to tell you that they've never had any liquid cooled problems, but, this what we ran into is not something that our customers would expect to see.
So in using this system, did this have GPUs as well?
There actually are. So we do, of course, support GPUs on the platform.
Yeah.
Frontier and Perlmutter and others have lots of GPUs. We did not make our GPUs on this system available to the students. Frankly, we just don't have very many in the system, and the benchmarks that we presented, I can let Cheng and John talk more of those. Certainly, there are GPU versions of them, but we presented kind of the CPU version.
But the real important thing is everybody had a level playing field from a hardware perspective.
Correct. Yeah. So we set up the system so that each team could only run one job at a time. They could queue as many as they wanted. And there were absolutely teams that did queue many jobs, and utilization was not uniform. But I think, right, the harder you work, the better you'll do. And I think we can clearly look at the usage. And there was one team that far outstripped the others, and I think they finished second and third in the overall performance. So, effort pays off.
It does.
We've seen that in the student cluster competition last year, that the teams who took an iterative approach to figuring out what are the different parameters of this problem, how do I tune it this way, how do I tune it that way, instead of just sitting there thinking about it, and I'm going to give it one run, let's try to improve on the last score that we had, figure out what we can do to get the score up. That was very successful last year, and it sounds like you've seen more of the same.
I think definitely yes. Now, another factor, again, just in the real world, the nodes, normally we have a process to kind of clean nodes between runs if you have any kind of memory leaks. And I know towards the end of the week, we did run into some issues where some of the nodes were, I guess, just getting sleepy. And we don't have the same crack team of administrators on our training system that typically our customers would use. So there may have been some impact to students, but again,
real world
and testing is important, right?
And do your work early.
That
don't wait.
Doesn't hurt.
We had a lot of procrastination on this first event, but that's not unusual. College kids, right?
Sure.
But it's a valuable lesson they've learned. And speaking of valuable lessons, Cheng, I'd like to bring you into this and talk a little bit. I believe you are the HPL LINPACK guru for the team, right?
No, I'm sorry. Cheng was. I'm doing HPCG. Yeah.
Oh, I'm sorry. I thought the other way around. So tell us about how you trained them on HPCG.
So for HPCG, I tried to give them some context of why would run solvers like HPCG. So I started with a physical problem. Well, of course, HPCG is solving a three-dimensional heat transfer problem. So I started with a physical problem. It's described by a partial differential equation, and we use numeric method to solve the partial differential equation. So we end up having a discretized system such as the one we have with HPCG. And to solve the physical problem, we need to introduce, as Zach mentioned, some concept of domain decomposition. So we would decompose the compute resource into the XYZ dimensions, and that's part of the input for HPCGs. So we go from there. Then we end up having to solve the normal linear systems of equations, A times X equals to B, and HPCG is an iterative solver to solve AX equals to B. So it's a little bit different than your normal just pure linear algebra kind of thinking. We also try to loop in the concept of using computer to do numeric analysis of a physical problem. We end up having to solve A times X equals to B. And HPCG input does require some understanding of that process.
Excellent.
Yeah.
And I saw your training course. It was very good. And John, you did some of the training too as well, right?
Correct. Just for the HPL side of things. And, Cheng, Cheng could have easily covered both topics. He's a guru at all aspects of linear algebra. But for HPL, we did sort of a similar thing. But just with, background on what it's doing, solving this large system of equations, and a little bit on top 500 and how it forms the basis of the top 500 rankings, just so that they kind of see where this ends up being used in industry comparisons, and then just diving into how to run the code and some basic suggestions for tuning it. I didn't really want to overwhelm them with, like the HPL.dat tuning, input file has a lot of options. And frankly, many of them don't really matter, particularly at the single node level. So we just kind of gave them some hints on things they might want to focus on in the limited time that they had on the system to improve the result, and gave them a target in terms of the theoretical peak performance of the nodes and how close could they get to that for their 2-node jobs. We basically assign them to get the best 2-node performance for HPL and the best 4-node performance for HPCG.
Excellent. And I noticed that the teams, some of them actually did pretty well. Yes,
some of them came pretty close to 80% efficiency.
Yeah.
These particular processors, low 80s is very good without like additional tuning at the
Not heroic measures.
Right. And, going into some of the, the SMU settings for the power management for the processors and stuff like that. But with the basic settings that they have in place, I thought that a number of teams did very well.
I would say so. If you're talking about getting close to 80% efficiency on LINPACK, we're used to looking at professional organizations, top 500 runs. We're talking about students who just got their first introduction to HPC, and they're coming out of the chute and learning how to do it. I think that's fantastic. How did they take to it? Were there students who were particularly enthusiastic about it?
That's a good question. Certainly there were a number of students who reached out a number of times. A few had problems with running into out of memory problems and things like that. And so, and that too is as Chris would say, a real world HPC experience. So in those kinds of interactions, they got to a little better understanding of how the input file parameters related to system memory usage and those kinds of things, and eventually made their way toward, getting that, the level of performance that we were talking about. I think there were a number of teams that did fairly well, and even the ones that, weren't quite near in the high 70s were still respectable. There were only a couple that had, I'd say, some problems with, maybe just misunderstanding of what the goals were, things like that.
It happens. It's early in the competition. This is the first challenge they've had in this area. So you can expect some of that, I think.
Yeah. And as you said, a lot of them, this was their first exposure. So, to do what they did, there's a lot to absorb. If you've seen Chris's training, there's a lot of material.
There's a lot to absorb in Chris's training. Chris's training.
If it were that easy, we wouldn't need these student cluster competitions. People would show up on day one and just go do it.
Right.
Yes, exactly. But we just can't thank HPE and you folks enough for pulling this off. I know that there were heroic measures taken because there was a major upgrade of the machine going on just beforehand that we had to sweat it out day by day. Would it be ready? But you pulled it off magnificently, as always. Thank you.
This is again typical to HPC, right? There have been heroic measures taken on large HPC Cray EX supercomputers to get a top 500 run on LINPACK in under the deadline. We've seen that in recent history.
Well, and Cray and HPE have always kind of valued and prioritized, customer intimacy and really partnering with our customers. So yeah, it's a very collaborative, very, very give and take. And myself discounted, but the majority of the people here are phenomenally intelligent, capable people, but they're also putting in a crazy amount of work. And
yeah. Oh, absolutely.
I think that's just this industry.
It is. But you guys are a fine example of that, and one that all should strive to achieve.
Yeah, I'll add my thanks to Dan's. This mentorship of the students is what makes these student cluster competitions work. And if we can light the spark in some of these students, get a love of supercomputing into them and get them into our industry, that's exactly what we're trying to do here. And I sincerely appreciate your help in introducing these students to supercomputing.
Thank you again.
Our pleasure.
And
It's totally our pleasure. Yes. We agree completely with what you said.
Hope we meet up again next year and do it all over again.
That would be great.
I can't speak for the company, but I think that's what we want to do.
Fantastic. Well, we will set a date. I
Sounds
will lock that in. Well, thank you again, and we will talk to you soon. Bye-bye.
Cheers. Thank you.
Bye.
Thank you.